CS 3351 Digital Principles and Computer Organization. Topic is Datapath. Presented by Devi Visalakshi, Assistant Professor of CSC Department, Rohini College of Engineering and Technology. Building Datapath. Building Datapath having the following sessions. First one is a single cycle datapath, multi-cycle datapath, pipeline datapath. Single cycle datapath. Each instruction executes in a single cycle. Multi-cycle datapath. Each instruction is broken up into a series of shorter steps. Pipeline datapath. Each instruction is broken up into series of steps. Multiple instructions execute at once. Difference between single cycle and multi-cycle datapath. Single cycle datapath. Each instruction is processed in one clock cycle. Two separate memory units for instructions and data. Multi-cycle datapath. Divide the processing of each instruction into 5 stages and allocate one clock cycle per stage. Single memory unit for both instructions and data. Single ALU for all arithmetic operations. Extra registers needed to hold values between each steps. Instruction register hold the instruction. Memory data register hold the data coming from memory. A and B hold operand data coming from the registers. ALU out holds output coming out of the ALU. Creating a single cycle datapath. The simplest datapath will attempt to execute all instructions in one clock cycle. This means that no datapath resource can be used more than once per instruction. So any element needed more than one must be duplicated. We therefore need a memory for instructions separate from one for data. Although some of the units will need to be duplicated, many of the elements can be shared by different instruction flows. To share a datapath element between two different instruction classes, we may need to allow multiple connections to the input of an element using a multiplexer and control signal to select among the multiple inputs. A reasonable way to start a datapath designed to examine the major components required to execute each class of MIPS instructions. Let's start at the top of by looking at which datapath elements each instructions need and then work our way down through the levels of abstraction. When we show the datapath elements, we will also show their control signals. We use abstraction in this evaluation starting from the bottom up. Datapath element, a unit used to operate on or hold data with a processor. In the MIPS implementation, the datapath elements include the instruction and data memories, the register file, the ALU and adders, program counter. The first element we need a memory unit is to store instructions of a program and supply instructions of given an address. The register containing address of the instruction in the program being executed. Lastly, we will need an adder to increment the PC to the address of the next instruction. This adder, which is combinational, can be built from the ALU simply the writing control lines so that all the controls always specifies an add operation. We will draw such an ALU with the label add to indicate that it has been permanently made an adder and cannot perform the other ALU function. To execute any instructions, we must start by fetching the information from memory to prepare for executing the next instruction. We must also increment the program counter so that it points at the top of next instruction. So this is a diagram for instruction memory, program counter as well as adder. A portion of the datapath used for fetching instructions and incrementing the program counter. The fetched instruction is used by other parts of the datapath. Or format instructions. To perform any operation, we require two registers. Perform an ALU operation on the contents of the registers and write the result to a register. We call these instructions either OR type instructions or arithmetical instructions. These instructions includes add, sub, and OR and SLT. The processor 32 general purpose register are stored in a structure called register file. A register file is a collection of registers in which any register can be read or written by specifying the number of the register in the file. OR format instructions have 3 register operands, so we will need to read two data words from the register file and write one data word into the register file for each instruction. For each data word to be read from the registers, we need an input to the register file that specify the register number to be read and an output from the register file that will carry the value that has been read from the registers. To read a data word, we will need two inputs, one to specify the register number to be written and one to supply the data to be written into the register. The register file always outputs the contents of whatever register numbers are on the read registered input. Writes, however, are controlled by the write control signal, which must be asserted for a write to occur at the clock edge. Datapath segment for branch instruction. For computing the branch target address, we must also determine whether the next instruction is the instruction that follows sequentially or the instruction at the branch target address. When the condition is true, the branch target address becomes the new PC and we say that the branch is taken. If the operands are not equal, the incremented PC should replace the current PC. In this case, we say that is branch is not taken.